Hello everyone, I'm Matthew Blackman. Today is April 27th, 2025, and this is my Week 3 assignment for FTT 122, Introduction to Ammunition and Basic Ballistics. So for this week's assignment, I'll be going over it in 3 parts. Part 1 is going to be me explaining what the difference is between an explosive and a propellant, so let's begin. The major difference between an explosive and a propellant is the burn rate. A propellant burns fast, but in a controlled way, while an explosive releases energy very quickly, often creating a shockwave and destroying things. A propellant is able to create gas that builds pressure and launches the bullet forward. However, if we were to use an explosive in the same manner, it would result in a catastrophic failure, not only not launching the bullet as intended, but also destroying the cartridge and likely the firearm as well. Think of it like a grenade going off in your chamber. And for part 1, my sources are, of course, the SDI textbook on Intro to Ammo and Basic Ballistics, as well as an article from the NRA on propellants in hand loading from January of '81. Okay, so for part 2 now, I'll be going over my opinion on if the firearms industry should find ways to move away from current propellants. So my opinion is really going to be based on the term, if it's not broke, don't fix it. Firstly, I'd like to say I'm all for development with propellants. However, I honestly don't think there's a real need to move away from current propellants at this point. Smokeless powder has worked reliably for a long time, and it's proven itself over and over again. If it's doing the job safely and effectively, why mess with it? Unless there's a big reason to change, like major safety or environmental issues or a specific application, I'd say stick with what works. If it ain't broke, don't fix it. Lastly, for part 3, I was asked to draw a cross-section of all 3 types of primers described in chapter 6 of the SDI textbook and describe how these designs work and the purpose of various primer designs. Now, I'm horrible at drawing, so I tried my best to use some drawings online as a base for mine, but they still didn't come out the best, but they will do. So let's start with the battery cup primer. So when the firing pin hits the primer, it crushes the primer compound between the anvil and the metal cup. This generates enough heat to ignite the powder in the cartridge. The battery cup design is simple and cost-effective, but generally doesn't handle as much pressure or provide as consistent an ignition as the Boxer or the Berdan. Next, we'll be looking at the Berdan primer. So when the firing pin strikes the primer compound ignites and the flame goes through the 2 flash holes to ignite the powder in the cartridge. The Berdan primer is commonly used in military ammunition and other non-reloadable cases, as its 2-hole design is less convenient for reloading. And lastly, we'll be looking at the Boxer primer. Upon impact from the firing pin, the anvil inside the primer cup is pushed forward, compressing the primer compound and igniting it. This ignition generates enough heat to start the combustion of the powder in the cartridge. The Boxer primer is easy to reload because it has a single central hole for the anvil to push through, and this is what I personally have the most experience with reloading. Again, this was my week 3 assignment for FTT 122, and thanks for watching.